NASA's James Webb Telescope just photographed something that breaks everything we know about the universe. Galaxies that existed before they physically could, and scientists have no explanation. In July 2022, the James Webb Space Telescope sent back its first deep-field images, the most detailed photographs of distant space ever captured. Within weeks, astronomers noticed something impossible. Massive, fully formed galaxies appearing just 300 million years after the Big Bang. According to our current models of physics, these galaxies shouldn't exist. They didn't have enough time to form. Yet there they are, captured in infrared light that traveled over 13 billion years to reach us. The James Webb Space Telescope can see farther back in time than any instrument in history. It detects infrared light, which allows it to peer through cosmic dust and observe the earliest moments of the universe. When astronomers analyzed Webb's first deep-field images, they identified 6 galaxies with a critical problem: their redshift values. Redshift measures how much light has stretched as the universe expands. The higher the redshift, the farther away and older the galaxy. These 6 galaxies showed redshift values between 10 and 13. That places them between 300 and 500 million years after the Big Bang. In cosmic terms, that's practically yesterday. But here's the problem. These aren't small, primitive galaxies. They're massive. Some contain as much mass as 100 billion suns. They have well-defined structures, spiral arms, densicoids, all the features of mature galaxies that should take billions of years to develop. According to the Lambda CDM model, our standard model of cosmology, galaxy formation follows a specific timeline. First, tiny fluctuations in the early universe create regions of slightly higher density. Gravity pulls matter into these regions. Dark matter halos form. Then hydrogen gas collects inside these halos. Stars ignite. Galaxies gradually take shape over hundreds of millions of years. This process requires time. Lots of it. Current models predict that large, mature galaxies shouldn't appear until at least 1 billion years after the Big Bang. Webb found them at 300 million years. That's 3 times faster than physics allows. Stars form when gas clouds collapse under gravity. This process has a maximum speed. You can't make stars faster than hydrogen can cool, condense, and ignite nuclear fusion. NASA's calculations show that even under perfect conditions, forming 100 billion stars takes at least 500 million years. These galaxies did it in 300 million. Dr. Ivo Lab, an astronomer at Swinburne University, led one of the teams that analyzed these galaxies. His paper, published in Nature in February 2023, stated the problem clearly. Quote, "These galaxies are so massive, they shouldn't exist this early. They challenge our entire understanding of galaxy formation. Mass doesn't appear from nothing. Every atom in these galaxies had to come from somewhere. In the early universe, matter was distributed almost uniformly. Small variations in density, about 1 part in 100,000. Gravity amplifies these variations over time, pulling matter together. But this process is slow. Computer simulations run by NASA and the European Space Agency model this precisely. They input the known laws of physics and let the simulation run forward from the Big Bang. In every simulation, galaxies this massive don't appear until 800 million to 1 billion years. Reality disagrees with the simulations by 500 million years. It's not just their size. It's their structure. These galaxies have organized shapes. Spiral arms require rotational stability that takes time to establish. Dense cores require multiple generations of star formation and gravitational settling. The images from Webb show galaxies that look mature, like they've been evolving for billions of years. But they're only 300 million years old. Theory 1. Dark matter behaved differently. Some astrophysicists suggest dark matter might have clumped together faster in the early universe. If dark matter halos formed more quickly, they could have pulled in regular matter faster. This would accelerate galaxy formation. But this requires dark matter to behave differently than it does now. We have no evidence that dark matter changes its properties over time. Theory 2. Supermassive black holes. Another hypothesis involves supermassive black holes. If massive black holes formed very early, they could have acted as gravitational anchors. Their intense gravity would rapidly pull in surrounding matter. Stars would form faster around these black holes. Webb has actually detected supermassive black holes in some of these early galaxies. But this just creates another problem. How did black holes millions of times heavier than our Sun form so quickly? Theory 3. Our model is wrong. The most radical possibility is that the Lambda CDM model, our standard model of cosmology, needs revision. Maybe the universe didn't expand uniformly. Maybe the distribution of matter was lumpier than we thought. Maybe dark energy behaved differently in the early universe. Dr. Mike Boylan-Colchin from the University of Texas published a paper in Nature Astronomy in March 2023 suggesting exactly this. His calculations show that if matter was distributed differently in the first 100 million years, these galaxies become possible. But changing those initial conditions affects everything else we know about cosmology. Webb continues observing these galaxies in more detail. Spectroscopic analysis will measure their exact chemical composition. This tells us how many generations of stars lived and died to create the elements we see. More generations mean more time. Fewer generations support the idea that these galaxies formed impossibly fast. In October 2024, Webb identified another 15 candidate galaxies with similar properties, all massive, all appearing far earlier than models predict. If confirmed, this isn't an anomaly. It's a pattern, and patterns demand explanation. Some astronomers are proposing entirely new physics, modified gravity theories, alternative dark matter models, even revised estimates of the universe's age. Every option requires rewriting fundamental cosmology. The James Webb Space Telescope was built to answer questions about the early universe. Instead, it's raising new ones we never thought to ask. Galaxies that formed too fast, structures that organized too quickly, mass that accumulated impossibly soon. Either our understanding of physics is incomplete, or we're missing something fundamental about how the universe began. These 6 galaxies, frozen in light from 13 billion years ago, are forcing scientists to reconsider everything. The universe just got a lot more complicated.